Hello, everyone, and thanks for attending my virtual flash talk here at the Blue Innovation Symposium. Obviously, things are a little bit different this year compared to our previous years, but hopefully we can all connect in the near future. My name is David Shea, and I'm the Senior Vice President of Engineering for Kraken Robotics Systems. Today, I'm going to talk to you a little bit about some of the technologies that we've recently been developing and some of the projects that we've been working on, particularly in Atlantic Canada here. So for those of you who aren't familiar with Kraken, a little bit of background. We've been in business since about 2012. We started with about 6 employees. Today, we're about 135 people worldwide. We specialize in marine robotics technology and sensors and subsea equipment, primarily focused on defense, although as you'll see in today's presentation, we've been expanding more into the commercial market as well. So Kraken are really experts in maritime robotics technology. You can see a number of the different tools and capabilities that we have here. We do a lot of our own modeling and simulation, computational fluid dynamics, FEA, that kind of thing. We develop a lot of our own artificial intelligence software solutions. We build our own sensors, acoustic synthetic aperture sonars, optical underwater laser scanners, and we build our own hardware. We build pressure tolerant batteries, thrusters, and underwater systems. And we combine all those technologies into a few different platforms. Our catfish towed system, you can see there on the top, the Thunderfish, which is our untethered autonomous underwater vehicle in the middle there, and a subsea docking station. Today, I'm primarily going to be talking about the catfish system. So when we started our business at Kraken, we were primarily focused on product sales. We've been building and delivering sonar systems and sensors, and we expanded into building our own components, being the batteries and thrusters. We started moving up market into building our own platforms, our own towed underwater vehicle, and eventually our autonomous underwater vehicle, being the Thunderfish system. But more recently, we've actually been diversifying our business into a service-based business model, what we're calling robotics as a service and data analytics as a service, or RAS and DAS. And that's really what I'm here to talk to you today about. So the Ocean Vision project is Kraken's proof of concept project of our robotics as a service business model. So this is a project under the Canada's Ocean Supercluster initiative. It was the first project approved under the Ocean Supercluster. So over the course of this project, which is about 3 years, started originally in 2019, we're developing a number of technologies. We're building out a fleet of vehicles, and we're deploying those vehicles in and around Atlantic Canada, collecting very large quantities of very, very high resolution seabed data and repurposing all of that data to our different partners. So we have oil and gas companies, we have government organizations, we have commercial fishing entities, and we have defense participation as well. So the purpose of this project is really to demonstrate that we can collect data in the same areas and repurpose it for different requirements, different entities. We can also reduce the cost of that data acquisition significantly by bringing down the number of people that are required to be on the vessel, bringing down the size of the vessel that's required by leveraging these different robotic technologies, and ultimately reducing the carbon emissions as a result of these survey plans. So the Sea Scout system is what I'm going to be talking about today. It consists of a number of components: our catfish towed sonar system, our autonomous launch and recovery system, our tentacle electric winch, our remote link, which can operate over either a satellite link or a line of sight radio link, the operator console, which can exist on board the vessel or on shoreside location. So the core of all of this system, the Sea Scout system, is really our synthetic aperture sonar technology. So I won't go into the details here, but just suffice to say, synthetic aperture sonar is a very, very high resolution seabed imaging sonar. And one of the unique properties of synthetic aperture sonar are that the resolution is constant regardless of the range that we're operating at. Whereas traditional sonar systems, the beam will spread and the resolution will get worse the further away you are from the platform. So why does that matter? Well, that allows us to cover larger areas in shorter periods of time with higher resolution and giving you full confidence of the objects that you're going to see there on the seafloor. So to provide a more concrete example of that, here is some surface-mounted multi-beam data that was provided to us by our hydrographic service. So this was a shipwreck that was unidentified offshore Nova Scotia. We were investigating this. This is about a 1 meter by 1 meter resolution. Hard to tell exactly what it is or even if it's a wreck at all, but we suspected that this was a man-made object. When we went out there with our synthetic aperture sonar, of course, an order of magnitude higher resolution, we can tell immediately It's definitely not a warship or any kind of historical artifact. It's definitely a barge out there. And then when we start to look at the backscatter, then we get down to 2 centimeter by 2 centimeter resolution. We can get a much higher resolution image and actually identify what this wreck is and confirm that, yes, it was in fact a barge. To give you a different example, when we're talking about offshore infrastructure, these are some mooring chains that we had imaged using our synthetic aperture sonar system. So we can see the individual links in the chain there. But more importantly, once we start to identify an area of interest on the chain, we can actually go in with our underwater laser scanner system and provide a 0.9 millimeter resolution image of those same objects, giving you a very, very high resolution image of the structure down there to identify what the different objects are, what might be the corrosion or the integrity of that chain. So in summary, I just wanted to leave everyone with a couple of points. Commoditization of technology, all these technologies that we're talking about now, synthetic aperture sonar, underwater laser scanners, these are all off the shelf, commercially available, ready to deploy. Data is really cross-sectoral in that when we're out there collecting these data sets, they can be repurposed into different requirements for different groups, different entities, whether it's government departments or different commercial entities. And resolution matters. Ultimately, being able to inspect these objects, being able to identify these objects, and it helps to inform ultimately making better decisions in terms of safety, in terms of identifying objects out there in the environment. Thank you very much, and I would welcome any questions via email, or please reach out to myself or Shauna Cody, our marketing manager, who will be attending as well. Thank you.